Okay, so this recording is going to be out about a think, pair, share exercise that I usually like to do in class, and when opportunity permits, and of course, here in the lockdown we can't. So let's see here, sharing screen. So here's the question. Um, this is about this method from the pre-lectures about how to show that a list of functions is independent. This very specific category of functions, functions that look kind of like this. We saw an example in the pre-lecture. And so our hapless friend Bob is going to try to apply that same idea to this particular list of functions, trying to show that this is an independent list. And so his reasoning is, well, look, we argued something about the limit being 0, and we multiplied by e to the negative 2x or whatever it was to make the limit equal to 0. And so, but hey, look at this. This is already, limit's already 0. So why multiply by anything? I mean, what's the point of multiply? Can't I just go ahead and run with this as is and start making arguments about, well, the limit is 0 and therefore. Okay. So is Bob right? Is what we're asking, or, to be more precise, in what ways is he right and in what ways is he wrong? Okay. Now, one of the nice things about this being a recording is that y'all can pause and think about this on your own, and I don't have to wait. All right. So I'm going to say, go ahead and pause now. Think about it. Look back at the stuff in the notes, and you might even listen to the recording again if you like. And think to yourself. I think this is a good exercise. Take a moment, think for yourself. In what ways is Bob right, and in what ways is Bob wrong? So I'm going to assume now that you can hit the pause button and go ahead and do that. Welcome back. I hope you had the opportunity to give that some thought. And now let's just go ahead and talk about the answer. Well, he is right that the limit of this is 0 as is without multiplying by anything. However, do we care? So is that useful information? Let's sort of extend, the argument. So here's what we have. This function, we're going to set it equal to 0, because keep in mind, we're interested in the question of linear independence. And the way we arbitrate a question of linear independence is we look at this equation, specifically being that it is a relation, namely that linear combination adds up to 0. And then we ask questions about these coefficients. Specifically, I need to know, might these coefficients be significant or must they be trivial? Right? That's what decides the question of independence. So it's not whether the limit is equal to 0. In fact, it's sort of a given the limit's equal to 0. If we're looking at a relation, this function as a whole is 0. Of course, the limit's 0. The question is, what can we do with that? Okay. All right, so that's equal to 0. We take the limit. Again, of course, that limit's equal to 0. And what do we conclude about this? And the answer is nothing, right? This tells us nothing. How could I draw a conclusion about these coefficients C1, C2, and C3? This limit's equal to 0 for all possible values of C1, C2, and C3. The fact that this limit is equal to 0 is therefore not informative. It's obvious. Okay. All right. So that's what Bob's wrong about. Yeah, I guess technically he can take the limit, but he's wrong in thinking that it will be helpful to him, that the argument works. Okay, so let's now look instead at what Bob should have done. What Bob should have done is multiply first by e to the x before taking the limit. And specifically, having done that, he gets this equation, right? That's what you get by multiplying. Then take the limit. Oh, oops, sorry. Then take the limit of both sides. Of course, you get 0. And what can we do with this? Right, how is this useful? How is this more useful than what Bob was going to do? Well, this term and this term, the limit is obviously 0. So I don't need to know anything about C1 and C2. Those terms will go away. However, this one does not. Now, Bob's point of view on this of we need the limit to be 0, isn't it good when the limit is 0, is actually wrong, right? We don't want the limit to be obviously 0. We want to have something left over that's not obviously 0. And that's what actually allows us to draw a conclusion here, right? Knowing that this limit is 0 is what tells us C3, because there's only one value of C3 that would allow for this to be 0. Right? Okay, so this, now of course there's more to be done, but this is, in particular, this is what has allowed us to draw a conclusion, right? We're looking at this linear combination, trying to draw conclusions about C1, C2, and C3. And now, good news, I've drawn a conclusion about C3. And then we can repeat the process and further draw conclusions about C1 and C2. Okay. All right. So as I've been kind of hinting all along, it is the fact that one of the terms is not obviously going to 0. Right, well, I'll circle it up here. One of the terms, this term, the fact that it's not obviously going to 0 is what allows us to draw a conclusion about that coefficient. Okay. All right, so I think this is a nice exercise. I want to confess this, the argument, the method from the pre-lecture of how do we argue that this, a list of functions of this category, is or is not linearly independent. It is subtle. And I think this little think, pair, share exercise does a nice job of illustrating one aspect of the subtlety. So I hope that's useful.